Hi everyone, and welcome to this presentation today about exploring ZIO Prelude, the game changer for type classes in Scala. My name is Jorge Vasquez and I'm a Scala developer at Scalac. And by the way, if you haven't heard about Scalac, we are a software company in Poland. We are a fully remote company. So for example, I work from Bolivia in South America, and we have several other developers that work not just from Poland, but several countries around the world. So if you want to know more about the company, if you have any questions around the recruitment process and the company projects, you can ask Maya. Maya is a member from our talent team that is currently connected to the chat room. So if you have any questions, just let her know and she'll be happy to answer them to you. So what's the agenda today? First, we're going to talk about the motivations around ZIO Prelude. Then we're going to give a quick tour around the library. We're going to take a look to 4 specific scenarios. The first one, how to validate data using ZIO Prelude. Then how to combine data structures, how to traverse data structures, and how to execute pure computations. So what are the motivations around ZIO Prelude? First, some background. Functional Scala was born in Haskell. Scala Z took proven machinery in Haskell and ported it to Scala. So Scala Z has been forked then and replicated into other libraries. But Scala is not Haskell, because Scala is a language that combines object-oriented and functional programming in one concise, high-level language, but Haskell is a purely functional language. Also, Scala doesn't have everything Haskell has. For example, it lacks of full type inference and adds more performance overhead. However, in the other side, Scala has things that Haskell doesn't have. For example, it has powerful subtyping and powerful declaration side variants. In conclusion, we need a Scala first take on functional abstractions, and ZIO Prelude gives us that. So ZIO Prelude gives us a modular hierarchy that relies on subtyping, declaration side variants, and great type inference. Also, ZIO Prelude gives us no Haskellisms. For example, we don't have app on applicative. ZIO Prelude doesn't over-rely on unit and doesn't use invariants. Uses declaration side variants everywhere. Also, we have minimal implicits and less indirection. So now that we have taken a look to these motivations around the library, let's start our tour of ZIO Prelude. And by the way, this is something I forgot to mention before. If you have any questions around the presentation, you can just post your questions in the chat room, and I'll be happy to answer them at the end of this presentation. So ZIO Prelude is a small library, and today we will cover just a smaller part of it. If you want to know more about the library, you can take a look to the ZIO Prelude GitHub page. And let's take a look now to our first scenario, validating data. So what's the motivating example we're going to use? A very simple one. We want to validate a person data. So we want to check that first name is not empty, last name must also not be empty, and age must not be negative. So what will be our first approach? I'm going to use the either data type that comes with Scala. So as you can see here, we have a person data type that has 3 fields. First name, that is a string, last name, also a string, and age, that is an int. And here below, we have 3 methods for validating each of these fields. For example, we have validate first name, which takes a first name, which is a string, and returns either a string error message, or a valid string containing the first name. So if the first name is not empty, we return a right with the given value. Otherwise, we return a left containing an error message. In this case, first name must not be empty. The other two methods for validating last name and validating age are very similar. And here we have a smart constructor, make, that will take the 3 fields required to build a person, validate them, and finally returning a valid person if all these fields are valid, or it will return an error message, a string error message in other case. So what will this take? We are short-circuiting on failure. So in this case, the first validation error was on first name. So now no other validations are executed and the program immediately fails. So that's a problem. And if validation errors exist, because of this, we just get the first one when we should get instead the whole list of errors that happened. So we can try, and in this case, I have a much more complicated implementation of the smart constructor. So before validate first name, validate last name, I used a for comprehension, but that was short-circuiting. So I needed to implement my own logic to consider all the validation errors that can happen and return all the validation errors in a list manually. So now my smart constructor returns an either of a list of string that will be the list of errors that could happen when trying to create this person, or a valid person. But this code looks really ugly and we have just 3 fields, and you can imagine what would happen if we would try to implement if we add more fields. It will be, but if we call an invalid person, we get the behavior we wanted at the beginning. So now we get a list with errors happen. First name must not be empty, last name must not be empty, and age must not be negative. So that's better, but we still have some problems. Well, now we've valid of all the errors, that's good. But however, it was painful to achieve that. So you've seen that awful code that I needed to write to make this work using the either data type. So what we can do? Well, it turns out that ZIO Prelude has a very nice solution for this case, and this is the validation data type. The validation data type is very similar to either, but it has 2 cases. So one case is the failure case, and in that case, it can fail with a non-empty chunk of errors. You can think of a chunk like if it was an array. It's a functional array, basically. But it also is non-empty, so that's a nice restriction. That means that if we have errors, we must have at least 1 error. And the other case is the success case. So in case this validation succeeds, it can succeed with a value of type A. So we have several methods for creating validation values. For example, we have validation.apply that receives any computation that returns a value of type A. So if this computation draws an exception, that exception will be catched, and it will return error of type drawable. Also, we can use validation.succeed, and in this case we receive a value of type A and immediately succeed with that value. So that's why this constructor returns a validation of nothing, meaning this is a validation value that can fail, and returns a success value of type A. And also we have the other case for failing a validation immediately. So we want to create a validation that immediately fails. We can provide an error of type E, and this will create a validation of type E and a success type of nothing, meaning it can't succeed. we have constructors, so we can convert either's, options, and to validation values, and we can also convert these assertion values that come from the ZIO library to validation types. Is a constructor for combining several validations into one. For example, several validations, up to 22 validations, into just provide a combining function that receives values of the validations and combines them into just one. Just one. 1 minute. Just checking video quality. Maya is helping me here with video quality, but I'm just checking. Okay, so I didn't realize that we were having some connection issues. Let me reset my connection. Okay, so I've changed my Wi-Fi connection, so I hope it gets better now. Okay, I've changed my connection, resetted it, so I hope this goes better. So Maya, what do you think now? I've restarted the stream. So can you, Maya, receive a better stream now so I can continue? Okay, so I'll just I think I'll just proceed for now, and Maya, please let me know if the connection is better. Okay, okay, cool. It seems like now my slides are displaying correctly. Okay, so I'll just proceed, and Maya, please let me know if we are having any more internet issues. Okay, so let's continue. As I was saying, we have several constructors for combining several validations into just one value. For example, we have map par n that receives several validations, up to 22 validations, and you can combine them using a given function. So if all the validations succeed, you will get a succeeded validation, but if one or several of them fail, you'll get a validation containing all the errors that happened when trying to combine the validations. So that's better than what we had with either. We can also have, we also have a similar constructor named tupled par that instead of, it doesn't need a function for combining the validations, it just combines the success values of the provided validations into a tuple, also up to 22 validations. And if you need to combine more than 22 validations, you can use collect all par that receives an iterable of validations and returns a validation that can succeed with the list of values produced by these validations, or a non-empty chunk containing the possible errors that may have happened. And with these constructors I've already presented, you can apply several operations on them. So these operations are concrete operations that are defined on the validation data type in the ZIO Prelude library. So for example, you can map over the success channel of the validation. You can map over the error channel. You can also combine validations in a sequential way using flat map as either. So that means that if you want to use validation in a sequential fashion, you can also do that using for comprehensions. You can, for example, zip two validation values into one. You can convert them to eithers, options, tries, or even to the ZIO data type. So let's try again this validation scenario, but now using the validation data type. As you can see, these private methods for validating first name, last name, and age are pretty similar to what we had before, but now instead of using either, we are using validation. So now, for example, validate first name can either succeed with the first name if it is non-empty, or it can fail with an error message, and similar for the other two cases. And now, if we want to combine these validations, we can use map par n, which is this constructor that allows us to combine several validations, and we just have to provide the function to combine the success values from the three of them to yield a new person. So that was a lot easier than before. We didn't need to do anything manual. And now, if we try to make an invalid person with an empty first name, empty last name, or negative age, we have a failure with a non-empty chunk containing all the errors that happen. So for example, first name must not be empty, last name must not be empty, and age must not be negative. So that's a lot better. And we didn't need to do any manual logic. And if we add more fields to this person data type, it will be really easy to add them. We have just to add new validations to this map parent constructor. So a lot better. Benefits of the validation data type: we have no implicits at all. We have concrete methods, several methods, as you have seen. I've I have presented just some of them here. And we have automatic error accumulation in non-empty chunk. We don't need to write any custom logic for combining all the possible validation errors. And that's it for our first scenario. Let's take a look now to a second scenario, which is about combining data structures. So for this case, we want to combine these two nested maps, and these maps contain stats inside of it. These stats are simply counters, and the idea is that we want to merge these two nested maps. So these maps basically represent statistics, some statistics, counters by region, by country and region. So for example, here we have Bolivia, that's where I live. We have United States, we have Poland, and we want to combine these two maps into just one. And at the moment of combining stats, we want to sum them. For example, if we look at these statistics for La Paz and we want to combine them with these other stats, if we have here a none and here a sum of 10, the result should be sum of 10. If we combine sum 20 with this other sum 20, we should have sum 40 and so forth. So our first take will be the following. We have this stats case class, which has 3 counters, which are of type option long. And here this stats data type has a combine method that receives another stats to combine with the current stats. And for this case, well, the idea will be just combining each counter pairwise, right? So counter 1 of this instance with the counter 1 of that instance, and the same for the other 2 counters. So for this case, I'm using flat map for combining them because they are options. And we have this custom combine method that combines these 2 nested maps into a resulting map. As you can see, this logic looks really scary, and we don't even have really deeply nested maps. Maybe we could implement this in a more generic way to support more levels of nesting. But the important thing here that I want you to see is that this logic is really complicated, even when not having too much nesting level. So this looks really awful. And what happens if we try to combine them? In this case, for example, if we combine counters 1 with counters 2, if we combine La Paz here with this La Paz here, we should get num plus sum 10 should be sum 10, but we are getting a non-value. So we are losing information, and that's something we don't want to happen. So there is some problem with the code I've written before that's making this occur. So we have a bug implementation, and it was really painful to implement. And having this bug implementation is something that can happen very easily because the logic was complicated to implement. So let's give it a second try. So the original problem, I'm going to return some slides back. The original problem was with this combine method in the stats case class. Why? Because here for combining these counters, which are options, I'm using flat map. And the problem of flat map is that it's short circuiting. So if this self counter 1 has a value of none, that means this flat map won't be executed, so it will return a value of none. So this logic doesn't execute even if when that counter 1 is a sum of 10, for example. So that was the error there, the problem. So now for fixing that bug, we need to implement a custom logic for combining these counters, which are options. And here you can see I needed to write this pattern match sequence. So if we have both of them are some values, I can just sum them. If just one of them is present, I just return that value, and I return none if both of them are none. I needed to do this, and it wasn't something straightforward. This combine method is basically the same. I didn't need to change anything here. And now, when we try to combine these two nested maps, now we get the expected results. For example, if we combine this none with this sum of 10, we get sum of 10. That was the expected behavior. And if we combine some 20, with some 20, we get some 40, and so forth. So now the logic is correct, and we have no bugs. So that's better than before. However, we still have the problem that implementing this was really painful, especially the combine method. So what solution does ZIO Prelude have for us for this case? Is the associative type class. The associative type class, as you can see, is a type class that has just one method, the combine method, that allows us to combine two values of type A and return another value of type A. And why this type class is called associative? Because it follows this combine operation follows the associativity law. That means that if we try to combine, for example, A2 with A3, and by the way, this symbol here is just an alias for the combine method. So if we combine A2 with A3 first, and then we combine that result with A1, it should be equivalent to combining A1 and A2 at first, and then combining the result with A3. That's why this type class is called associative. So ZIO Prelude has associative instances for Scala standard types. So we have instances for booleans, for ints, for longs, for options, vectors, lists, sets, tuples. So ZIO Prelude already provides us with those instances. And of course, we can create instances of associative for our own types or for types that come from third-party libraries. So now let's try again, but this time using ZIO Prelude. So before, for combining stats, we had a combine method. Now, instead of implementing that combine method all by ourselves, I'm going to implement an associative instance for stats. So here I'm creating that instance, and creating that instance means to implement this combine method. In this case, we need to combine two stats to return other stats. So I'm just returning that stats here, and as before, we just need to combine counters pairwise. But on this case, I don't need to implement any custom logic for that, because I can just use the combine method that comes from ZIO Prelude, from the associative type class, that already knows how to combine these counters. Why? Because if you look at the type of the counters, you see that they are options. So ZIO Prelude already has an instance of associative for option. That means ZIO Prelude already knows how to combine two options between them. And also it knows how to combine longs. And here's something weird. As you can see, I've introduced this sum type, wrapping this long, which is the counter type. Why I needed to do that? The reason for doing that is that when combining longs, there are several ways of combining longs. For example, you can sum them or you can multiply them. So you need a way of telling ZIO Prelude what's the binary operation you're going to use when combining longs. On this case, I'm telling ZIO Prelude that I want them to combine, I want it to combine longs using summing them. This sum is called a new type. And the idea of new types, this new type, by the way, is also implemented in the ZIO Prelude library, has the advantage that only exists at compile time. So at runtime, this sum of long will be treated just as a simple long. That means that adding the sum type won't cause any runtime overhead. So that's the idea of new types. And coming to this combine method for stats, you can see that combining counters is really easy. We just use the combine syntax for this from the ZIO Prelude library. So now, and also if you look, I didn't need to implement any combine method for combining the nested maps. I just can call combine between these counters 1 and counters 2, and ZIO Prelude will already know how to combine them because ZIO Prelude already has instances for map and already has instances for option. The only instance that we needed to provide was for stats. So we don't need anymore to write any custom logic for combining nested maps, and we get expected results. So that's great. That's a lot better than before, a lot more easier. So benefits of associative: it doesn't lose information, as you've seen, and we have new types to select binary operations. So for this example, I've used the sum new type, but you have other new types already present in the ZIO Prelude library. So that's it for this scenario. Now let's take a look at our third scenario, which is traversing data structures. So the example for this will be the following. Process lists of raw events where each event consists of a timestamp and a description, and return either a list of valid events or a list of errors found while processing the events. So on our first attempt to solve the problem, we have the following. We have an event case class, which has a timestamp of type long and a description of type string, and we need to validate them. So this is very similar to what we had in the validation scenario. And for validating, I'm just returning either's. So validate timestamp, we return either an error message if the timestamp is negative, or a long if the timestamp is a positive value. Something similar for description. So here again, I'm using the either data type. And for collecting events, we have this method collect events that receives a list of raw events. These raw events will be simple tuples of int and string, representing the timestamp and the description, and will return either an error message or a list of valid events. So here, as you can see, I needed to use fold right, and this logic looks a little ugly to implement. So now, for example, I have these two lists of raw events. The first list contains just valid events. All of the timestamps are positive. All of the descriptions are not non-empty strings. And we have a second list. Let me check. Okay. We have this other list where we have some invalid events. For example, here we have a negative timestamp, we have an empty description. Here we have an empty description again, and here we have a negative timestamp. So if we call this collect events function on the first list of row events, we get a rect value with a list containing all the events because all of them are valid. But if I call collect events on the second list that has some validation issues, we return a left with just this error, timestamp must not be negative -2. That means when traversing this list of row events, we have found this -2 validation error and we just returned that. So that's again a problem because we would want to have a list of all the errors that happened, not just the first one. So this is not what we need. Problems with take one, we have a fail fast implementation because we are using either again, and it was a little difficult to implement collect events. So we needed to do some foldings and some complicated stuff. So let's see now our second attempt. In my second attempt, what I've done is changing the either data type by the validation data type that we have just discussed about. So we have these validation methods now return the validation data type, and again I can use map par n to validate the timestamp and the description of an event. I still have this collect events method. That's something that's custom logic, but on this case we are combining validations and not either the data types. So we still need to implement this custom logic. So what happens now? If we call collect events on the row events list, the first one, everything goes okay. We get a success value with a list of the events. And if we get a failure, with on this case, we get a non-empty chunk containing all the validation errors that happened while traversing this row events to list. So now we have timestamp must not be negative -2, description must not be empty, and all the errors that occurred. So that's better. However, we still have the problem that it was a little difficult to implement collect events. So that's something that ZIO Prelude can help us with. So what's the solution? It's the Traversable type class. The Traversable type class is basically just one method, the for each method, that can apply a function to each element of any traversable f. So for this case, our traversable was a list, but can be any collection data type. And just by implementing this for each method, we get a lot of methods for free. These methods here are methods that you can find in any collection data type. But the great stuff here is that you just need to implement this one and you get all of the rest for free. You don't need to implement them by yourself. So ZIO Prelude has traversable instances for Scala standard types. Here are some examples. We have traversable for option, either, list, vector, map. And of course, as before, for the associative type class, we can also create instances of traversable for our own collection types, and also for any other types that come from third-party libraries. So, on our third attempt to combine this row event, to traverse these row events lists, now we don't need to implement any custom collect events method. Now for traversing these lists, we can just call the traversable instance for list and call its for each method. So in this case, I'm saying that for each element found in the row events list, I'm going to convert it to an event object. As you remember, this event make returns a validation data type. So at the moment of traversing this list, if there are validation errors, they will be automatically collected into a non-empty chunk. And we can do the same for row events too. And now, if we check for the case of the second row events 2, we have a non-empty chunk with all the errors as before. But the difference here is that we didn't need to implement a custom logic for collecting events. We can just use this traversable instance for list. So that's a lot better. And a second example, just for showing you that you can implement traversables for any collection data type that you have, I'm going to show you an example of traversing a binary tree of futures. So here I have a binary tree data type that has 2 constructors. It can be a leaf with a value of type A, or it can be a branch. That means it will have a left binary tree and a right binary tree. I've also added a map method to this binary tree data type. And here you can see I have created a traversable instance for this binary tree. And for that, I just needed to implement the for each method. And as I've mentioned before, the good thing about this is that having implemented the for each method, I can have all the other methods that come from the Traversable type class for free. So that's really great. And here, for example, I have an echo method that receives a string and returns a future of string. It just echoes the string after some period, in this case 1 second. And I have here this tree of messages. And now, if I want to apply this function to each of these strings and return the results into a future, I can just do messages.forEach. This for each comes from ZIO Prelude. It's not a concrete method that I implemented on the binary tree data type. And I'm saying that for each of them, I want to execute the echo function that returns a future. So if all of these succeed, we are going to get a future containing a tree with the results. So as you can see here, if I print the results, I get the same tree with the same original structure, but now I get these echoed messages. Benefits of the Traversable type class: it works on all Scala collection types, and just by implementing for each, we get a lot of additional methods typical of any collection data type for free. Okay, now let's take a look to our final scenario, which is about executing pure computations. So the example for this will be the following. We need to write a program that, given a user ID, looks for the user's name and age, and then if the user's name is Jorge, the program should fail with an error message saying that you can't ask for Jorge's age. Otherwise, if user's age is less than 50, the program should succeed with a log message including the name and the age, and otherwise the program should succeed with no value. So here we have the first attempt to solve this problem using monad transformers. As you can see, the implementation looks really scary, and the problem is not really complicated at all. It's a very simple problem to solve, but using monad transformers you can see how complicated this code gets. So I'll just try to explain a little bit about this code. I have 2 mock methods here, get username and get user age. These methods return readers, and these readers just wrap functions from ID, that's the user ID, from a name, or to a name or to an age. So these are just mock implementations for now. We also have this log function that just receives a string and returns another string. And here's the program. So what we're trying to do here is we have these reader monads that are readers of long and string. And we need our program to fail, right? We're saying that in some cases our program should fail. Well, in the case that should fail is when the name of the user is Jorge. It should fail saying that the user, that you can ask the age of Jorge. So I'm using here the either transformer to state that I need to add the effect of failure to this reader monad, because the reader monad originally doesn't have the effect of failure. It can just succeed with a string in this case. But by adding this transformer, I'm saying that now it can fail with a string error message. But also I need to add other effect. If you look at the program statement, you can have cases where the program should succeed, but with an empty value. So I need to add the effect of optionality here. And that's why I'm adding the option transformer. So now I have this stack of two monad transformers over this base monad, which is the reader monad. And now for making all of this work, I need to do a lot of lifts here. I'm not going to go into the details of the code and why you need to do this, but you can see here these lift f's everywhere here. You can see a lot of type annotations here, here, here. So it's really crazy, a lot of type annotations. And I'm using this kind projector plugin that comes with Scala that makes writing these annotations a little simpler. If I didn't have this kind projector plugin, these type annotations will look even scarier. So that's some awful code. And just by looking at this, it's really hard to understand what the program is doing. So now if I run the program with an ID of 10, I'm going to get a name of Jorge, and in that case I'm going to get an error. You are not allowed to know Jorge's age. If I run the program with an ID of 150, I'm going to get an age of 50. In that case, the program succeeds with a known value, and in the other case, it succeeds with a log message. What were the problems with the first take using monad transformers? It's complicated to implement. Types are not inferred at all. That's why I needed to write all of those type annotations to make the code compile. And it's slow. So the more monad transformers you stack here, in this case I've just stacked two monad transformers, but the more you stack, the more slower your program will be. What's the solution that ZIO Prelude offers to monad transformers is the ZPure data type. As you can see, it has 5 type parameters. So if you know ZIO and you thought ZIO had a lot of type parameters, you were wrong, because ZIO just contains 3 type parameters, and now ZPure contains 5. So that's 2 more. And what is ZPure? This is the description that you can find in the source code in GitHub. ZPure is a purely functional description of a computation that requires an environment R and an initial state S1, and may either fail with an E or succeed with an updated state S2 and an A. Because of its polymorphism, ZPure can be used to model a variety of effects, including context, state, and failure. So the mental model for this ZPure data type is like this. You can imagine it's like a function that receives a context or an environment of type R, then it requires an initial state of type S1. That means this ZPure also includes the effect of state. This will be the effect, the reader effect. This is the state effect. So if you provide an initial state, you get an updated state S2 and either an error or a success. So that's the mental model you can use to better understand this data type. So ZPure, also if you look at the source code on GitHub, you can see that ZPure has some type aliases. For example, if you want the state monad, it's just a ZPure which has an S1 of type S, S2 of the same type S, doesn't require any context, any R. That's why here we have this any. It can fail, that's why we have this nothing here, and it can succeed with a value of type A. So instead of having to write all of this all of the time, we have this type aliases. The similar things we have for reader, or for a state that can fail, or for a reader that can fail. And you can have other combinations as well. So let's take a look now at the second attempt for solving the problem, now using ZPure. As you can see, get username and get user age are very similar. Now they return ZPures, but here I'm using just the reader type alias. It's not the same reader I used before. This is a ZPure, but I've used the type alias. So in ZIO Prelude, for create a reader, you can create a reader from a function. So that's a little different from what we had before. And the most interesting part is the program value. This program value will return an e-reader. That means this is a value that requires a long to run. The long is the user ID. It can fail with a string, and it can succeed with an option of string. This option of string will be the log message that may be returned to the user. So here, by looking at the code, you can see that you can clearly see what's the logic. It's not like before that we had a lot of type annotations and we needed to do a lot of lifting. Here you can see in a straightforward fashion that first you get the username, then you get the user age, then if the username is Jorge, you fail with an error message. Otherwise, if the user age is less than 50, you succeed with a log message, and otherwise you succeed with an empty value. So it's really easy to see the program logic, and it's not mixed with any lifts and a lot of type of annotations like before. So for running this program value, we can provide an ID, and see the ZPure data type has this provide method for providing the environment that it requires. In this case, it requires a long to run. The long is the user ID. And with run either, you can convert this ZPure value or e-reader to a either of a string, option string in this case. So if you run the program, you get the same results as before. But now we have a lot of benefits. This was simpler to write and simpler to understand. It has great type inference, and it's a lot faster than modal transformers. We are not doing any stacking of transformers here. We just have a data type with several type parameters. So that's it for this presentation. I hope you liked it, and I hope you find it useful, and I encourage you to take a look to the ZIO Prelude library. Well, as I've mentioned before, we have just seen a smaller part of the library. There's a lot more to take a look at, but I hope this has been interesting for you and that it motivates you to investigate more. Special thanks to Scalac Functional World for hosting this presentation, and also to John the Ghost that helped me with guidance and technical checking on this presentation. And once again, thank you for attending. And if you want to learn more about ZIO Prelude, you can also take a look to this talk if you haven't already. Reimagining functional type classes. That was the first talk that John DeGose and Adam Fraser gave on ZIO Prelude. You can find it in YouTube. If you want to contact me, you can contact me on Twitter or by email. Here's also my GitHub username. So thank you, and now it's question time. I've seen that Maya has posted me some questions here. Okay, it says in other languages, well, we have the angle brackets for representing combine. In other languages, that means different, same as the, okay, I find it a bit confusing. Is there another operator for combine? There isn't. Currently, ZIO Prelude has the angle brackets type alias for representing combine. So currently there isn't other type alias. And other question, what if you use libs and cannot use new types? Well, the idea of new types is, I don't know if I got the question right, but the idea of new types is that you can combine them with any other type. You can combine them with your own data types or with types that come from external libraries. The idea of these types is that they just help ZIO Prelude to decide how to combine two values of that type. For example, as the example I've shown, if you want to combine longs, it helps decide the way that you are going to combine them. And also something that I haven't covered in the presentation is that you can create your own new types. So if you have some new types that aren't present in the library, you can create your own new types. So that's also a great feature from ZIO Prelude that I wasn't able to show today, but you can certainly use that. Maya, I don't know if you have any other questions for me. Okay, so we have new questions. So I'm just waiting Maya to show me the questions. I can see the chat window here. Okay, but if one uses external lib, we cannot add a new type to the method signature. Okay. So maybe for, I don't know, I suppose there are several solutions for this. Maybe just writing wrappers around that will be a solution for using new types. I don't know, there are several techniques that we could use. And okay, other questions. Thanks a lot for the presentation. I'm wondering, for the last example, will it be simpler to go with neither ZPure nor Moda transformers, but just to use the types from Scala standard library? I'm trying to see the point of using either ZPure or Moda transformers for that simple lab. Yeah, you're right. Well, for this example was really simple, as you say, but I just wanted to highlight that the benefit of ZPure is overcoming the problems you have with monad transformers. Obviously, for this case, you could implement just using Scala standard types because it's a really simple problem. But in the real life, where you really need to implement solutions using monad transformers, you should consider using ZPure instead, because it will help you to reduce a lot of complexity and also get more performance than with transformers. Okay, so Maya, do we have any more questions? Okay, so it seems we don't have any other questions. Well, if you still have other questions, you can. Oh, okay. Oh, here I see another question. Let me. Yeah, I see one more question. If I have pure computations, why would I choose ZPure over simple standard library types? Well, you should use ZPure when you have effectful computations. For example, if you want to use if you want functions that have the state effect, or have the reader effect, or have the optionality effect, or the failure effect, that's when you should use this ZPure data type. Obviously, if you need a function that just returns an int, for example, you don't really need to use ZPure. You will use that when you try to return effectful values. And the other option was using monotransformers, but as we have seen, that's more complicated. And okay, I think that's it. So if you have any other questions, you can just contact me by email or Twitter. And I hope you like the presentation, and thanks for watching. So see you online, and thank you. Bye bye.